Today, we're answering the question, is any flywheel design inherently more consistent in its shooting than other designs? I'm Brogan Pratt, and I've been teaching robotics design for over a decade now. Today, we're going to run through 3 common flywheel setups: a single flywheel on a backplate, a dual horizontal flywheel, and a dual vertical flywheel. And we're going to experimentally test them and isolate as many variables as we can so that we can see, is any flywheel design inherently more accurate than a different design? And you might want to know this information because if one flywheel design is inherently more consistent or inherently more accurate than a different flywheel design, it allows you to take a look at one and think which base design fits my robot packaging the best, and then how can I lay it out, and which one may be more worthwhile to do some initial testing on. So let's take a look at the testing setup quick here. I've got a 2x30 amp RoboClaw controller here. This is connected to a Y splitter, which then goes to both of my motors. One of them is in reverse. I have it single encoder on one side measuring. Yes, I know that's not going to be perfect RPM on one side, but because it's consistent across tests, we should be able to get an accurate reading here. To make sure that I have a constant feeder going all the way through, I'm going to be grabbing a ball through my little hopper here. I'll be lining up at the back of the hopper, and then I have a little arm here that when I drop, it should consistently have the exact same amount of pushing force in the exact same position on each ball, so hopefully get a little more accuracy there. And then I am about 2.5 meters away from my grid pattern here, and on my grid pattern, I effectively have 5 squares evenly spaced 5 centimeters apart from each other with a center axis, so we should be able to get a radial graph as to how consistent is our cluster. I'm not super concerned about absolute accuracy right now, but what I am concerned about is how consistently are we hitting in the same quadrant, so we can actually take a look at the radial graphs at the end. We're running 6,000 RPM motors from GoBuilda, and I have a PID controller, so I can keep these things going at about 1,200 RPM, give or take about 4%. Now the setup for the vertical flywheel shooter is effectively the same as horizontal. I've just taken it, pivoted up on the side, and I've added in this cross bracing here so that you can actually see the whole table shaking with this, so that this thing doesn't have any sort of lateral instability, so we can still get ourselves some pretty consistent shots with it. So let's go ahead and get some testing on this. Taking a look at this single flywheel setup, I have 2 bare motors constrained across the same axle to a single flywheel, and then it's on top of a same piece of, it's the exact same hopper as I've used for the previous 2 tests. It's also going to be running at the same RPM as the same previous 2 tests, so we can try to get somewhat consistent results, at least the best we can in these different setups. I have had to move my electronics up to the top because I don't have a long enough cord to be able to reach my encoder. Let's take a look. Let's go ahead and take a look at some of this data here. Now for the single wheel launch on 30 points, we ended up having a pretty consistent cluster, give or take about 10 centimeters cubed. So blue is obviously 4, was able to hit -1.5 and -2.5. And again, this is not talking about absolute accuracy. What we're looking here is looking at consistency of clusters. So there's a few outliers here, but you have a relatively decent, probably about 30 centimeters on your x-axis on a single wheel launcher. On a dual horizontal launcher, you have quite a wide spread here. There was one point we were able to get a little bit of consistency in the middle, but we end up having just a really wide swath. So again, this is just one data point on a single setup. But looking at this data, a dual horizontal launcher is not very accurate at all. And a dual vertical launcher ends up having quite a bit of vertical accuracy. There's a few outliers on the outside here, but for the most part, it's actually pretty accurate. So let's go ahead and look at both of these side by side. So let's look at the two that seem to make the most sense. We've got a single launcher here and the vertical launcher over here. So looking at these two data points side by side, it is a challenge to decide which one you'd actually want to go with, be a single wheel launcher or a dual vertical launcher. It's pretty clear that a dual horizontal inherently, at least based off my test, may not be the most accurate at launching itself. That may be because it's hard to keep both wheels spinning at the same speed to be able to launch them out consistently. And that might be why you kind of have these large variations in left and right. Now, the single wheel launcher, you may have some of this accuracy because this is the ball that's most likely to give yourself that Magnus effect or that back spin, which is going to reduce some of that wiffle effect of having those balls in those circles. Same thing with this dual vertical launcher. You end up having pretty accurate vertical consistency. Now, the thing to recognize is that this test is on a 2D plane, an X and Y axis, but you're actually launching into a 3-dimensional plane, more on a triangle there as well. So you end up having a little bit more depth here. So perhaps a little more consistency in height may be more accurate in that this launcher here was more consistently on a Y axis, whereas this was more consistent on an X axis. But for our purposes of getting things into a goal on an FTC, perhaps that's more where you want to go. But if your project is more less height constrained and more narrowly vertically constrained, maybe a dual vertical launcher may be the way to go. These are not the only flywheel designs that exist, but I'll leave this to you to decide what you want to actually do with this data. Because to be honest, at this point, it kind of depends on how wide your goal is and how far it is you're going. If you're using this for the FTC decode season, I would say either of these are a great starting point to be able to move off of further. If you're designing a dual horizontal launcher, perhaps you might want to consider swapping to a different design because you might have one that's more inherently accurate than the other, at least based on this initial data points. If you want access to the full testing data, you can consider joining the community down below as well as the CAD so that you can run some of these prototypes yourself if you'd like to. Let me know in the comments down below what your thoughts are. What kind of shooter do you think makes more sense based looking at this data? Does a single wheel launcher look more appealing? Does a dual vertical launcher look more appealing? I think it's a bit of a toss-up between the two, and you could make fantastic arguments for either ones. Otherwise, I hope you enjoyed taking a look at this experiment, and best of luck on your next robotics project.